Okay, today we have the lesson 5.4 video, which is all about factoring. Factoring should be a review from Algebra 1, but we're going to go over a bunch of these to make sure we have these down. As you can see, we have a table of a bunch of different factoring techniques. Part of this table will be on that blue sheet that you have that you can use on quizzes and tests, but we want to make sure that we have practiced them up so we know how to use the table when we get to those problems. So the first thing you want to do whenever you are asked to factor is look for the greatest common factor. You can use these on polynomials of any number of terms, and so this is kind of one of the more important ones to be looking at. Now, how the greatest common factor one works is, again, as you can see in the general case, we have a trinomial, so we have three different terms here. Now, in each of these terms, we notice that there is an A and a B. So in this one, there's A and a B. And those are each to differing degrees, but we know that we have at least the A and the B. Now, none of our coefficients necessarily align. The first coefficient is hidden, it's just a 1. The second one has a coefficient of 2, and the last one has a coefficient of 4, or negative 4, because of the minus there. So we can't necessarily factor out a greatest common factor with the coefficient, but we can take out some of the variables. Now, again, in the first one, it's a to the third, b to the second, and each of those at least have a and b to the first power. The second one is 2. Again, we can't do anything with that coefficient, but a to the second, b to the first. Both of those have a to the first and b to the first available. And our third one is 4, or negative 4, because of the minus, a to the first, b to the second. And like I said, all of those have our a to the first and b to the first that we could take out of them. So when we look at this first one, when we take a to the first and b to the first out of that term, we're left with just the a squared and b to the first. A to the third went down to a to the second because we took one a out. B to the second, or b squared, went to b to the first because we took one b out. Similarly, when we look at the second one here, the 2 stays. We take one a out, leaving just a to the first, and we take one b out. And we only had b to the first power, so that b goes down to just a 1, which we don't necessarily need to write, so we're just left with the 2 and the a. So that's our second term there. And when we look at our third term here, again, 4, or negative 4, stays there. We're taking out a and b, which leaves us with no a's because we just had one a to begin with. We have b to the second power and taking one b out, so we're just left with 4b, but a negative 4b. So that's how factoring with the greatest common factor looks. Again, that's the first one that you're going to want to look at. Now, when we're looking at polynomials with 2 terms, there's a couple of different tricks that we can look at when we have the sum of 2 squares. So in the end, when our answer, or what we're given, is a squared minus b squared. Now again, a and b might be factors, so we might have like x squared minus y squared, or that one might even be a constant, so we might have x squared minus 25. Because 25 would be 5 squared. So how that would look is, it's kind of the reverse of foiling it. Our a squared minus b squared would become a plus b times a minus b. So again, down here I'll make an example. Say it was, like I said, x squared minus 25, which we recognize as 5 squared. That would become, according to our table, x plus 5 and x minus 5. And just to check and make sure that works, we can FOIL it out, and we say that x times x is x squared, x times negative 5 is a negative 5x, 5 times x is positive 5x, and 5 times negative 5 is negative 25. Now we notice that our negative 5x and our positive 5x subtract each other out. So in the end, we're just left with our x squared minus 25, which was what we started with. And so that's just a way to check and make sure that their difference of two squares, why that works. Now the sum of cubes, again, we can check the same way. It wouldn't necessarily be foiling, but it's kind of a double distributive rule. When we take our a times our a squared, that's where we get our a cubed from. But if we take our a by ab, that's going to give us, again, it's a negative ab, that would be negative a squared b. And if we have our a times the b squared, that would give us a positive a b squared. But now we have to look at our b times everything. B times the a squared gives us positive a squared b. B times our negative ab gives us negative a b squared. And b times b squared leaves us with that b cubed over there. And what we can notice is, again, we have a squared b term, one that's negative and one that's positive, so those subtract out. And we have an ab squared term, one that's positive and one that's negative. So those ones all subtract out, leaving just these two cubes over here, the a cubed and the b cubed. So again, that's just a way to check and make sure that that trick works when it does. Difference of two cubes is going to be very similar, only because we have that negative here. This and this, instead of before where we had a positive and a negative, they have to be switched. They have to have the negative and the positive. So in the end, when you take your, to be on this side, the negative b times b squared, that would end up over here with being a minus b cubed, but everything would still cancel out the way it did in our sum of cubes. Looking at some of our other ones, though, the perfect square trinomials, again, those we can look at just by foiling. And if we look at that, our a plus b squared is really the same as saying a plus b times a plus b. And if we wanted to FOIL out a plus b times a plus b, a and a become a squared, a and b becomes plus an ab, ba becomes plus another ab, and b become b squared. We have two different ab terms, so our final answer is going to be a squared plus 2ab plus b squared. And again, this checks out with our perfect square trinomial here. Again, similarly, when it is when we're using negative in the front here, it would just be the a minus b, because again, that looks like a minus b times a minus b. And if we were to FOIL that out, a minus b, a and a make a squared. A and negative b becomes minus ab. Negative b times a is another minus ab, and negative b times a negative b, the negative and negative makes positive, so it's plus b squared. So combining these like terms, we're left with a squared minus 2ab plus b squared. So this trick checks out. So anytime that, again, you can plug in something for a, it could be a variable, could be a constant. So like x squared minus 2x, say b was 5, like we looked at before, so that one would actually come out to a negative 10x plus, again, if b was 5, this one would be 25. you can factor it into this form. So that's kind of how the table works. Let's look at some examples of how to actually use what we are dealing with here. So again, if we're going to be factoring polynomials and we want to use our tricks, the first one we want to look at would be the greatest common factor. So in this case, our three terms that we're looking at, the 10a cubed b squared plus 15a cubed b minus 5ab cubed. Well, if we look at our constants, looks like our 10, 5, and our negative 5, we can pull a 5 out of each of those. We look at our a term, we have a cubed, a squared, and a. We can pull a to the first out of each of those. And we have b squared, b, and b cubed. We can pull b to the first out of each of those. And when we do that, we pull 5ab out of this first term. That would leave us with 5 out of 10 makes 2 left. A out of a cubed leaves a squared, and b out of b squared leaves a b. Looking over at our second one, 5 out of 15 leaves 3, because 3 times 5 is 15. A out of a squared leaves an a, and b out of b just leaves 1, which we don't need to write then. We can just leave that one as is. 5 out of negative 5, that would be negative 1. So we don't have to write the 1 part, but we do have to maintain that it is a minus. A out of a is still, again, 1, so we don't have to write that part. And b out of b cubed becomes b squared. So in the end, we're left with 5ab times this trinomial, the 2a squared b plus 3a minus b squared. Now once you get to here, you want to check and make sure that once you've taken the greatest common factor out, that you can't take anything else out of what we have factored. It looks like, according to our constant coefficients, 2, 3, and 1, we can't take anything out there. And we don't have any other variables, a and b, that are in each, so we can't take anything out there. And none of our other factoring techniques will work on this. So this is down to the final answer. That is as factored as we're going to get. So again, looking at some grouping will be our next one. When we group, we're basically just going to be looking at factoring different parts of it. So when we want to group, we'll look at this part and we'll look at this part. So if we look at our first part of our first problem here, x cubed plus 5x squared, well, we can take x squared out of both of these. Now when we do that, that's going to leave x plus 5. So we took x squared out of both of them. Moving on, we can look at our next set. We can take negative 2 out of both of these. And when we do that, that leaves us with an x, and 10 divided by negative 2 is plus 5. Now from here, we notice that we have x plus 5 in both instances, and we have x plus 5 being multiplied by x squared and by a negative 2. Now in that case, it's kind of the same as foiling, or that distributive process. We have our x plus 5 that we're multiplying in one instance by the x squared and in one instance by the negative 2. So factoring by grouping would give us, in the end, we have our x plus 5 binomial times the binomial x squared minus 2. So this would be our final answer. And if we wanted to check that, we would FOIL. X by x squared would give us an x cubed. X times negative 2 is negative 2x. 5 times x squared is plus 5x squared. And 5 times negative 2 is negative 10. And even though it's not exactly the same, our commutative property says we can flip these two around, which is going to make it look exactly like where we started from. So again, that just shows that our x plus 5 times x squared minus 2 is our factored form of that example. So let's try that again. If we want to look at our second example, we'll look at this part and this part. In our first part, we can take a squared out of both of these, and that's going to leave us with a minus 4. And if we look at our second part, we can take 3 out of both of our cases here, or both of our terms, and that's going to leave us with a, because 3 times a is 3a, and negative 4, because 3 times negative 4 is that negative 12. Now again, once we're here, we can notice that we have an a minus 4 in both sets, this time being multiplied by a squared, this time being multiplied by 3. So we bring that factor down even more into a minus 4 times a squared and times positive 3. So again, this is our final factored form. And to check that, again, we FOIL. A times a squared is a cubed. A times 3 is 3a. Negative 4 times a squared is minus 4a squared. And negative 4 times 3 is negative 12. Commutative property says we can flip this around, and that makes it look exactly like what we have there, the a cubed minus 4a squared plus 3a minus 12.